Okay, this question is about a pendulum, but the first part is about the speed of the combined masses. You've got a pendulum bob which is swinging down and colliding into an object here. Generally, when you have a collision, it's a momentum question, so we're going to say that the conservation of momentum happens. So m1v1 equals m2v2. The initial mass is the mass of the bob, which is 75 grams. The initial velocity is 0.8 meters per second. The second mass, after they combine, it says they move together, so it's double 0.75, which is 0.15. Times v2, which is what you want to calculate. If you calculate that out, that gives you a v2 of 0.4 meters per second. Show that the collision is inelastic. Well, an inelastic collision means kinetic energy is not conserved, so you have to calculate the kinetic energy before EK1, which is half mv squared, which is a half times 0.075 times 0.8 squared, which gives 24 millijoules. The EK after is a half mv squared, which is a half times 0.15 times 0.4 squared, which gives us 12 millijoules. So 12 millijoules is lost, so the energy is not conserved, which means it's inelastic. Okay, describe the changes in gravitational potential energy of the oscillating system from t equals 0 as it oscillates through one cycle of its motion. Well, from t equals 0, it's at the bottom, then it's going to swing up, and then down again, and then up, and then down again. So it's going to have the max GPE at the extremes of motion, and the minimum GPE at equilibrium, and the motion is going to be sinusoidal.